Section 10.3, Parametric Equations and Calculus. If a smooth curve C is given by the equation x is a function of t and y is a function of t, then the slope of C at the point xy is given by dy dx. The slope at xy is given by dy dt over dx dt, where dx dt is not 0. Now, our second derivative would be the derivative with respect to x of dy dx, which is the derivative with respect to t of dy dx over dx dt. You are frequently asked about the second derivative on the AP exam. So it's important that you know this. Notice that it is not a quotient rule. We're taking the derivative of y with respect to x and then taking the derivative of that with respect to x. So the derivative with respect to t of dy dx over dx dt. Now, dx dt is the rate at which the x-coordinate is changing with respect to t, or it's the velocity of the particle in horizontal direction. So dy dt is the rate at which the y-coordinate is changing with respect to t, or it is the velocity of the particle in the vertical direction. Dx dt dy dt is the velocity vector. Sometimes you see it done in parentheses, sometimes you see it done like this. Either way, here's your velocity vector at time t. Dy dx is the rate of change of y with respect to x, or the slope of the tangent line to the curve at any x, or the slope of the velocity vector. Those all have the same meaning. The second derivative is the rate of change of the slope of the graph with respect to x. The square root of dx dt squared plus dy dt squared is the speed of the particle. Also, it is the magnitude or length of the velocity vector. And the integral from a to b of the square root of dx dt squared plus dy dt squared is the length of the arc from t equals a to t equals b, or the distance traveled by the vector from t equals a to t equals b. Please listen to the example completely, and then you can write it down at the end of the explanation. We are given that x is 2 cosine t and y is 4 sine squared t. Let us remember, when we take derivative of that, it is going to be a chain rule, and let us remember that 4 sine squared t is 4 times sine t, the quantity squared. So dy dx is dy dt over dx dt. So the derivative of y with respect to t is going to be 8 sine t to the first power times derivative of sine t. Dx dt is going to be negative 2 sine t. Now, you can see that we can simplify this a tad, and we get that. So this is the slope of the tangent line. You need to be able to state what you found. That is how we find the slope of the tangent line. So now we are asked to find the second derivative. Now, the second derivative with respect to x would mean the derivative of my first derivative with respect to t over dx dt. You want to get used to writing that out. Well, this is super easy. The derivative of this with respect to t is 4 sine t. And the derivative dx dt, we have already found it, negative 2 sine t, and we get this. Now, will the second derivative always be a constant? No. What does the second derivative tell us? It is the rate of change of the slope of the graph with respect to x. Okay, pause the video and write down this example. Example 2. Find an equation of the tangent line to the curve at the given value. X is 4 cosine theta, y is 3 sine theta, and I want it at theta equals 3 pi over 4. Now, what do I need for an equation of tangent line? This is so old. You need a point, you need a slope. All right, so my slope, dy dx, is dy d theta over dx d theta. Dy d theta is 3 cosine theta. Dx d theta is negative 4 sine theta. I can write that as negative 3/4, and we know that cosine over sine is cotangent. Now I need to find my x and my y. So evaluating x at 3 pi over 4 and y at 3 pi over 4 gives me my point. I can find my slope at 3 pi over 4. Negative 3/4 cotangent of 3 pi over 4. There's my slope. Here is my equation of the tangent line. And in the family-friendly version, we can move this over. All right, take a moment to write down the example. Again, please give me a moment to explain the example. You will be given the opportunity to write it down after the explanation. For number 3, again, let me explain the example, and then you can write down the work at the end of the explanation. Find all points of horizontal and vertical tangency on the curve. Now let us remember, horizontal tangents means the numerator is 0, that the denominator is not. Vertical tangent means the numerator is not 0 and the denominator is 0. We know this, it's old material. So first we're going to find dy dx, which is dy dt over dx dt. And here it is. Look at that. There's no vertical tangent because the denominator is never 0. Neat. And as we move to the next part, let us remember froth. Fractions are our friends. So now we're going to find dy dt. Okay, when is dy dx 0? When the numerator is 0 and the denominator is not, and the denominator will not be 0. So dy dt is 0 when t is negative 3/2. Now, it says to find all points of horizontal and vertical tangency. All I have is a t value. I need the x and the y coordinates. So I know what t is. So I can find x, I can find y, and now I can answer the question. We have a horizontal tangent at the point negative 1/2, negative 9/4. Again, fractions are our friends. Leave it like that. Don't change it to decimals. All right, take a moment to write down your work for this example. Again, let me explain the problem, then you can write down the work at the end. Number 4, find the arc length of the given curve. X equals t squared, y equals 4t cubed minus 1, where t is between 0 and 1. This gets asked a lot on the AP exam. So our arc length is S equals, from A to B, the square root of dx dt squared plus dy dt squared dt. So I'm going to substitute in my dx dt, my dy dt, from 0 to 1, square them. What kind of cleanup work can we do? Well, we can factor a 4t squared out of each term, which allows me to bring 2t outside of the square root. And if I look at this, if my u is 1 plus 36t squared, my du is 72t. I have 2t, so I need to multiply that by 36. Multiply, divide by 36 gives me my u to the 1/2 du. I'm just getting it in the form because I'm too lazy. I don't want to switch those limits of integration. So we get 1 over 36, 2/3, 1 plus 36t squared to the 3/2, right? To the 1/2 becomes to the 3/2, coefficient of 2/3. The 2/3 can come out. 2 goes into 36 18 times. 18 times 3 is 54. And we are now looking at 37 to the 3/2 minus 1. And there is our decimal approximation. Okay, take a moment to write down this work. Okay, let's look at a FRQ style question. A particle moves in the XY plane so that any time t greater than or equal to 0, the position of the particle is given by x of t is t squared minus 1, y of t is t to the 4th minus 2t cubed. Find the velocity vector when t is 1. So what do we first need? We need dx dt, dy dt. velocity is dx dt dy dt. So here's dx dt, here's dy dt at 1. This is just another component, of what we've learned earlier. Find the acceleration vector. So acceleration is derivative of velocity. You always want to say that. And so our acceleration vector is 2 and 12t squared minus 2t when t is 1. For what value of t is the particle at rest? Our particle is at rest, okay, when the velocity vector is 0, 0. It's not enough to just say when the velocity is 0. It's when the velocity vector is 0, 0. So when 2t equals 0 and when 4t cubed minus 6t squared equals 0. Notice, t equals 0 makes dx dt 0. I have two values for dy dt being 0. The value I choose must be a value that makes both the x and the y of your velocity vector 0. And then we're going to answer the question. Your particle is at rest when t equals 0. It does ask for what value of t. Part D, by the way, we are speeding up when our velocity and acceleration have the same signs. We are slowing down when velocity and acceleration have opposite signs. Find the magnitude of the velocity vector. So that is our speed. It's denoted like this. Note, this is really, there's your velocity vector. It's really just your Pythagorean theorem. We can substitute in dx dt and dy dt, square them and add them. And when t equals 2, I just need to evaluate when t equals 2. And we get that to be the square root of 80, which is 4 square root of 5. Or another way you can do this is find your velocity vector at 4, 8. Y at 4, 8. Because t is 2, the x-coordinate of my velocity vector is 2t. The y-coordinate is 4t cubed minus 6t squared. We get that. And there's, again, our answer. This is the top part of the page. Take a moment to write down the work. This is the bottom part of the page. Take a moment to write down the work. Another free response question. At any time t between 0 and 2 pi, the position of a particle moving along a path in the xy plane is given by these parametric equations. Find the slope of the path at the time pi over 2. You will notice these are products. So dy dt, e to the t times the derivative of cosine t plus derivative e to the t times cosine t. Dx dt, same process. So dy dx is dy dt over dx dt. We get this. Dy dx evaluated at t equals pi over 2 gives us -1. Notice, you must be very particular with your notation. Part B, find the speed of the particle when t is 1. Speed is velocity. So ds dt, square root of dx dt squared plus dy dt squared. Substitute what we know. And you have some aloha to do. We need to square this binomial. Cosine t squared plus 2 cosine t sine t plus sine t squared. And again, I can pull out that e to the t from both of them. This is e to the t squared. This is e to the t squared. I can factor out both, and it gets to come out because it's e to the t squared. Again, I have e to the t squared times all of this, plus e to the t squared times all of that. The square root of e to the t squared is e to the t. So that's nice that that can come out. Combine similar terms. Notice that I have cosine squared plus sine squared. That's going to give me 1. Cosine squared plus sine squared. That's going to give me 1. I have 1 plus 1, square root of 2. These two terms are going to drop out. And there is my velocity, which is ds dt, is e to the t times the square root of 2. And now I can find it at 1. My velocity at 1 is e to the 1 times the square root of 2, which is when t equals 1, the speed of the particle is e times the square root of 2. Find the distance traveled by the particle from t equals 0 to t equals 1. So I'm going to look at s equals the integral from 0 to 1, dt dt. I'm going to integrate this. You know that that square root of 2 can come out in front. Integral of e to the t is e to the t. Substituting in from 0 to 1, fundamental theorem step, I get that. The distance traveled from t equals 0 to t equals 1 is the square root of 2 times e minus 1. Pause the video, take a moment to write this down. And the bottom part of the page. And your 10.3 TPs, 7, 13, 27. See you next time.